Welcome back to my channel, everybody. Sreetips here, and I've got some gold back here boiling in nitric acid, and you can see it's turned a little bit of a yellow color. And what we're going to do is I wanted to test that stuff with some stannous chloride, but my stannous chloride is out of date. So what we're going to do is we're going to make some fresh here. This is pure tin shot. I bought this on eBay. Takes about a gram of it, which is, I just pour a little bit out, about that much. It's about a gram. And then I'm adding some stannous chloride crystals, about the same amount. I will add this to our test bottle here. Here's the recipe that I'm using to make this stuff. And I'm going to add the material here into this bottle carefully. Next, I want to add some distilled water. And so what I do is I've got needs 25 milliliters, which is about right here. So I'm just going to add distilled water up to that point back there. Now I'll add hydrochloric acid. What it call for here? 30 drops of hydrochloric acid. I'll add that right on in carefully. That's a couple extra, that's okay. I'll put the lid on, shake it up. That's ready for immediate use. Let's go ahead and test our stannous that we just made. I've got some gold in solution in this container right here. It's a standard test solution. This 1 gram per liter. And we're going to test our testing solution and make sure it works correctly. And there you can see by that stain that it works correctly. Alright, we'll do another test here. This is with some distilled water. And you can see the test on distilled water is nothing. It doesn't react. Alright, let's do one more test. Get a piece of filter paper. I've got some platinum standard testing solution. Put a little bit of this on our piece of filter paper here. And we'll use some of our freshly prepared stannous. We should get a color reaction here. It should turn orange, which it does. That's verification that we have platinum in solution, and that our stannous chloride testing solution that we just prepared works properly. Let's try one more test. I have some palladium test solution here. These are standard test solutions that I can use to make sure that my my stannous chloride solution is going to work proper. And these standard test solutions serve also to give me some kind of indication of the concentration of metals that I have in solution, because these are a known quantity, 100 milligrams per 100 milliliters. All right, let's look at this palladium test. There's the palladium test. Here's our test strips: palladium, platinum, and our gold standard test solutions. So now what we'll do is we'll reach down in here, get a little bit of the boiling solution. This is nitric acid. It's gold boiling in nitric acid. And what we're going to do, if I can get some test solution on here before it dissolves the paper, you can see that that has put gold in solution. So boiling nitric acid back here will put traces of gold in solution. What I'll do now is take this nitric boil. This is about the 5th or 6th nitric boil on this gold. And I'm going to pour this off now into my silver jar, even though there's a little gold in there in solution. I'm adding this to my silver jar, and we'll recover the gold later on when we process that silver out of this silver jar. All right, here's our gold. I think what we're going to do is we're going to set this gold up on our hot plate here. There's about 40 grams of gold in here. And what we're going to do is now is add some hydrochloric acid. Well, let's see, about 250 milliliters, I guess, of hydrochloric acid. The gold has already started to dissolve. That's because there's some residual nitric acid in there. And so what we're going to do with this experiment is I've got some lead shot here, and I think what we'll do is add a few pieces of this lead shot into here as we dissolve the gold. I don't know how this is going to work or what it's going to do. I'm just going to put a few pieces in here. That's about maybe 5 or 6 pieces, 7 or 8 maybe. And now what we'll do is we'll start adding nitric acid and see if we can get this gold to dissolve. And then once we get it dissolved, I want to see if that lead shot is going to dissolve with the gold. Lead is terrible for gold. And so what we want to try to do here is dissolve that lead with the gold, and then see if we can detect it when we add sulfuric acid later on. So now I'll add some heat, and what we'll do is we'll start adding doses of nitric acid in here. Put it on time lapse now, and we're going to watch the gold dissolve and hopefully get that shot to dissolve in there too, that lead shot. This took about 2 hours to dissolve, and I still got some chunks of lead left down in there, and there's also some kind of precipitate, looks like, forming down in there. So what we're going to do now is we're going to take this off the heat, and we're going to set it down here and let it cool off. Let's get some ice in here. If you look down in there, there's still some chunks of lead that didn't dissolve. There's some kind of precipitate down in there. So what we'll do now is try to get this cooled off so that we can filter it. That precipitate down on the bottom of there? Not sure what that is. Get this poured through a filter. You see there's a bunch of junk down in there. Not sure what that is. Not sure that's associated with the lead or not. I think it is. I haven't put any sulfuric acid in here yet. Now let's see what we get out of this. Junk in there, man. It's not silver chloride, I can tell you that. I would never have that much silver chloride after those extensive nitric acid boils that I've done. There's a little pieces of shot up in there. Some of the lead shot did not dissolve. Here's what it looks like down in the beaker. Gold is pulling through at a decent rate, and solution don't look too bad, a little cloudy. So this might be either lead chloride or lead nitrate, because we've been using nitric acid and hydrochloric acid in here. So it won't be lead sulfate because we did not add any sulfuric acid. I just wanted to show you these tests one more time after they've dried out. The one on the left is gold, the one in the center is platinum, and the one on the far right is palladium. Now our compound is looking a white color, grayish white, maybe beige, probably because we're rinsing the gold out of it with some distilled water. It's got a little bit different color now. Looked yellow before, but I think it's a white powder. Probably going to be lead chloride from the hydrochloric acid in the aqua regia. Here's a close-up look at the compound. Let's see what we got here. This is our filter. What I'll do is, I'm not going to add that to my paper storage. I'm probably just going to trash it. It's probably some kind of lead. So what we'll do here now is I've got a new filter rig. We'll bring this up, get this ready to go. Now, we've got this filtered out. It's cloudy. I'm going to put a shot of sulfuric acid in here. See if we get any kind of precipitation or any reaction. I think I did see something there. A little bit of precipitate did form when I added that sulfuric acid, just a little bit. Let's put a new filter in this filter flask. Get this set up to go here. And if you look, do have some precipitate in there. It's formed. See it swirling around in there? That's from the sulfuric acid that we added. It must be the lead sulfate. The fabled lead sulfate that we all hear about. And the reason that we add sulfuric acid to our gold solution, and supposedly what I've been taught is that sulfuric acid will cause lead sulfate to precipitate out. The lead sulfate is insoluble, and so now we should be able to filter it out 100%. Oh yeah, I can see it in there. It's pulling through the filter very quickly, which is good. And if you look up in here, you can see there's some precipitate in that flask. And I don't think it's going to be silver chloride because I boiled that so long in the nitric. And this stuff came out of solution. Look at all of it. When we added the sulfuric acid. So that's going to be our lead sulfate, that white material right there in the bottom of that flask. Nice. Glad I did this to see what we can get when we add that sulfuric acid. See that junk in there? That's our lead sulfate. This stuff is insoluble in water and in acid, so I don't think it's going to hurt anything if we rinse it all down into our filter. Oh yeah, look at our filtrate now. Nice and clear. That's our gold solution. Alright, here's what's left in the filter. I believe that is going to be lead sulfate. Still got some stuff in there. It's cloudy, so we're going to run it through a filter one more time before we do the precipitation. Yeah, there's some precipitate that's settled out down on the bottom. Probably some more lead sulfate. You know what? Let's do this before we proceed here. I'm going to put another little squirt of sulfuric in here. See if we get any more precipitate to form by adding some fresh sulfuric acid. I don't see anything new. There's definitely some junk down in the bottom here that we need to filter out, so that's what we're going to do right now. Yeah, there's quite a bit of precipitate down in the bottom of this flask. Probably going to be lead sulfate. I don't think it went through the filter. I think it probably was still reacting as we poured it through the filter. And then after it pulled through the filter and got down into our flask, it precipitated out because of the sulfuric that was present. during that filtration. An emergency situation here. Gonna have to change flask because we got too full. Let's go ahead and transfer the solution. It's nice and clear now. I think we've got it all out of there. Let's transfer our solution into this beaker. Yeah, I don't see any traces of precipitate down in the bottom of this flask. So I think it's safe to conclude that we finally got all the precipitate out of there. We should have waited for a while to let the sulfuric acid react. I'm going to pull this funnel. I haven't rinsed it out yet. Still got some gold in it. I'm going to pull it off of here and just set it back out of the way temporarily so we don't rinse any of the precipitate down into the filtered liquid. Let's go ahead and put some stump out in here now. Stump out is sodium metabisulfite. I'm going to precipitate out the pure gold with stump out. Put in another spoon. And one more spoon. Maybe another half one. This should do it. There's only about 40 grams of pure gold in here. So this should do it for us. I see some yellow around the top here. Just put another quick spoon of stannous, or I mean another quick spoon of SMB. Now what we'll do, get a stannous test. These are pieces of filtered paper that I cut up. What we'll do is stick this down into our solution. Do a stannous test, make sure all the gold has in fact dropped out of here. And as you can see, that negative stannous test tells me all the gold has dropped. While I'm waiting for this gold to settle, let's go over here, take a look at our time-lapse experiment. This has been running about 4 days now, and we're starting to see some decent crystals growing down in there. So we'll publish this later on, probably next week. Should be about a 10-day time lapse of the electrolytic silver cell crystal growth down in the silver cell. Here's our beautiful gold powder. I've allowed it to settle completely. Now what we'll do is we'll pour off this waste solution into a waste container. Now what we'll do is rinse this off with some hot tap water. Here's the gold after our first refining. I'm adding hydrochloric acid, about 200 milliliters, and we'll put it up here on the heat and boil the gold in hydrochloric acid.
The gold has been boiling in hydrochloric acid for about 10 minutes. Now we're going to take it and dump off this hydrochloric acid boil into our temporary waste container. You can see there's some yellow color, which may be some gold in solution. That's okay, we can recover it out of that waste container later on. Here I'm going to rinse it a couple times with some hot tap water. And now what we'll do is just add some plain water, put it back up on the heat, and give it a boil in plain water.
It's been boiling gently in water for about 10 minutes. Now what we'll do is I'll reach in here and we're going to pour this off into our waste container. It's very clean looking gold, just like it is right there. Rinse it one quick time with some distilled water. Alright, this looks really good, man. The gold looks excellent for a single refining. And now what we'll do, so I'm just going to set it down here. We're going to get set up for our next evolution. Let's turn some heat on. This reaction takes quite a bit of heat. Now what I'll do is reach up here and we'll turn on some flow of hydrogen peroxide. Just a little bit. Just going to trickle it in there a little bit at a time. There we go. And I may even slow that down a little bit. What we'll do is we'll put this on time lapse and dissolve this gold a second time using hydrochloric acid and hydrogen peroxide. I believe everything has gone into solution. There may be a few tiny pieces that haven't dissolved yet, but I'm going to call it here. Let's turn our hydrogen peroxide off. Turn the heat off down here. Let me move my delivery apparatus out of the way. Just push it back out of the way. Now we'll scoot this back ever so carefully. Now we'll pull our gold solution down. Look at how clear and pretty that looks, man. That's just beautiful chloroauric acid solution. We'll pull it down, let it cool off. Before I forget, let's put some sulfuric acid in here and watch it closely to see what happens. See if we get any lead precipitating out of here. I'm just going to put just a little bit in there. I didn't see anything precipitate out when I added the sulfuric acid. I don't think there's any lead left in there. Doesn't hurt to put that in there anyway. You can see there's just a few tiny crumbs of gold left in there that did not dissolve. That's okay. We'll put that in the filter and add it to our paper storage. Here's a look at the silver cell. The electrolyte level is getting a little bit low again in this thing. The electrolyte level has to be monitored. And as well as what we want to do is add a little bit of silver nitrate solution to this, because the silver cell does become depleted of silver. The electrolyte does anyway. As the cell operates, it plates out on the cathode. So what I've got here is some silver nitrate. What I'll do is I'm going to add some of this right on in over here. If I can sneak this in without creating a disaster for myself, I'll pour some silver nitrate in here. What this will do is this will replenish the level, and it will replenish the actual silver concentration of the electrolyte, because the silver concentration declines as the cell operates, becomes depleted or low on silver. The electrolyte does. It plates out on the cathode, and so it's beneficial to add some silver nitrate periodically. The silver cell has been in operation for 5 days at this point. You'll notice that the current flow is 0.6 amps. What that means is the silver in the anode basket there has been consumed by the reaction. The electric current flow going through that anode basket dissolves that silver. This is impure silver shot or granules from cement silver that I've melted and poured into water. This is what I use as the feedstock for the silver cell. It's probably 98 to 99% pure silver. It's got an ugly color because there's a bunch of copper, or 1 to 2% copper in there, so that causes it to oxidize and look real ugly. But the silver will dissolve by the electric current flow. The silver ions travel through the electrolyte in that cell and then plate out as high purity silver on the cathode. Here you can see that the amperage has climbed back up now that we've got fresh silver in there. Cool this down so we can filter it. Look how clear and bright that solution is. It looks absolutely gorgeous. No traces of cloudiness. Beautiful chloroauric pure gold solution. Got a number 2 medium flow filter in our funnel. I'm gonna go ahead and wet it. Our solution is really looking just excellent here. Hardly any reason to filter it at all, but we're going to pour it through the filter. Here's what's left in the filter. Essentially nothing. Just a few tiny crumbs of gold that didn't dissolve. And if you look at our solution down here, crystal clear. Looks perfect. Let's take our filter off of here. Here's what we have in the filter. A few tiny pieces of gold. Nothing else. I'm transferring our gold solution. Shouldn't have any nitric in there at all. Because we didn't use any nitric to dissolve this gold. We used hydrochloric acid and hydrogen peroxide. Now we'll take my gold solution. We're going to put it over here on some heat. And we're going to evaporate this down as a little experiment here. I had some other footage of this. It was much more volume than this I started out with, and the camera died right away, so I didn't get much on that footage of the evaporation. But this is the entire amount. There's about 43 grams of pure gold in that solution. And I went over to help my daughter to hang up a picture, and I left it on the heat, and it got crispy. All right, I think we burnt the bacon. I don't know what that is, man. I hope we didn't hurt it. That's a couple $1,000s worth of gold right there. Take it down, let it cool off. Here's our gold solution, evaporated down to dryness. Folks have asked me what would happen if we went down to dryness. Now we know it forms these this red material. This is the chloride acid crystals, I believe. I've allowed this to cool down to room temperature. If you look down in there, it looks kind of like red. It's got a red color to it. And I'm not quite sure what we're going to do with this. Let me see if I can bust some of this loose. Yeah, it's loose. I can get the crystals to come loose down in there. See that? Some on the end of the spoon. That's probably a 1.5 grams of gold right there on the end of that spoon. It's going to be highly concentrated chloride acid crystals. And not quite sure what to do with this. So what we'll do is we're going to conclude the video right here until I figure out how to proceed with restoring the gold here. And we'll do that in a separate video. This will conclude the lead added video. I'd like to thank everyone for watching.